Howdy, we're Team Mean Machine. Our team has 4 members. Sam Costa in charge of the power, Jacob Jozwiak in charge of the structure motors, Lucky Barut in charge of the radio control, Miguel Garcia in charge of the microcontroller. Our project is to build a Battlebot prototype able to enter the Battlebot competition with some modifications. Our solution to this is to use the Battlebot rules for design considerations and constraints. This diagram shows that the robot receives signals from the remote and the MCU distributes these signals as commands to the H bridges that control the motors. Our deliverables are to supply power to all functions of the robot for a total of 4 minutes. We need a robust frame and motors for movement and weapons. We need to fully control the robot with the remote. We need to operate the robot with signals from the remote. Some quick specs. We wanted to keep it light in case we had to haul it around campus. We wanted the nominal voltage to be less than or equal to 48 volts. That comes from the Battlebot rules and regs. The recommended speed was approximately 4 miles per hour. We've got it up to 3.5 miles per hour. Range for the RC controls is about 100 feet. That was because of the size of the Battlebot arena. For battery life, we calculated that we need about 740 milliamp hours. We have 3250 milliamp hours. For the power design process, we made decisions off the demands from the motors and the microcontroller. We decided to use step-down DC-DC converters to all the components that make their specs. We partitioned the power distribution into 3 separate PCBs, 2 PCBs for the wheels and 1 PCB to the weapon and microcontroller.
For the structure, I learned how to use SolidWorks in order to get a rough estimate of the weight of the robot. From there, I was able to perform the torque calculation to select motors that met the torque demand. After that, I selected H bridges that could handle the power demand of the brushed DC motors. Ideally, we would have chosen brushless motors, but we decided to go with brushed for budget purposes. After that, I built the robot from scratch.
The radio controller on Arduino Uno was used to collect analog and digital data. XB series radio modules were used to transmit the collected data to the Zybo board through serial communication. All the components were then put together through a PCB that was designed through Eagle. The Zybo board also sends back GPS data, and the Arduino Uno uses an algorithm to calculate the distance to the designated location, and then the Arduino Uno sends back bytes for motor control.
For the microcontroller, I wrote code to drive the motors using pulse width modulation. I also developed code to acquire GPS data and send it to the radio control for future functionality. All this was done by configuring the UART interface for data transmission and the GPIO for debugging. I use a Xilinx board called the Zybo, which is half a microprocessor and half an FPGA. So half of my design was done in software and the other half was done in hardware. Here's a screenshot of my hardware design and a capture of the board that was used.
At the end of the day, we wanted our subsystems to be as dialed in as possible and integrate these systems into a functional prototype. This is a video of a weapons test. Our functional prototype driving off into the fog of war. Thank you for your time.